Okay, now that we know how to move from 1 mole of something in a balanced chemical equation to another mole in something, let us now add into our conversions that we've already defined based on our previous unit that we had earlier in the year. Okay, so let's kind of think about the mole bridge that I gave you before. Before, when I was moving from the mole to something, I always had to use the mole bridge, okay? But the thing with the mole was that every time I went to the mole and I was going to something else, I would go back outside of the mole using that mole bridge. And we only typically did 2 conversions, right? Now we may have to do more than 1 conversion because I need to move from the given to the mole based off the balanced chemical equation to the wanted materials on the other side using another conversion. Okay, and I kind of have steps to kind of help us figure out how and what my problem will look like. And that's why I always like to do factor labeling, because it gives me my question mark is the unit that I should end with, and my equals is the first unit that needs to be canceled at the bottom of my first conversion. Okay, so let's look here. In a typical stoichiometric problem, the given quantity is first converted into moles. Now, if you're given moles, you don't have to convert into moles. You're already there. Okay? If you're not given moles, you're always going to have to convert to moles first. Okay? Then the mole ratio is used from the balanced chemical equation, and then we're converting out of moles into whatever quantity we want. Now, sometimes the quantity we want is the mole. If it's not, we have to do another conversion to convert back out of the mole. Okay? Now, these questions always start with a balanced chemical equation, okay? But now that you know how to write them, that's always the first step. Always write a reaction and balance it first, okay? So let's look at this equation. Methane, which is CH4, reacts with steam to form carbon monoxide gas and hydrogen gas, okay? So let's write the reaction. So I have CH4 and steam, which you know steam is H2O. If not, I just told you. And we are creating carbon monoxide, which is CO, and hydrogen gas. Hydrogen's a Hofbrinkel, so it's going to be H2. Okay? And then I need to make sure that my reaction is balanced. Okay? So 1 carbon, 4 plus 2 is 6 hydrogens, 2 hydrogens here. So I need to put a 3 here, 1 oxygen, I'm balanced, okay? So I have a 1 to 1 to 1 to 3 mole ratio, okay? All right, so now I'm going to go back to this question for every single one of these statements, okay? It says, how many of the following are formed with 158 grams of methane when I react it with an abundant amount of steam, okay? So the first one says, I want to figure out how many moles of hydrogen gas I'll make, okay? So the first thing I need to do is, question mark, what am I looking for? So my question mark here is moles of H2 equals, my original given was 158 grams of CH4, okay? Let's set up a conversion. The first thing I have to do is go to the mole, because I can't move from one quantity to another through grams. I need the mole because that's what I get from the balanced chemical equation, okay? So grams of CH4 is going to go on the bottom, and moles of CH4 goes in the top. Now, if you remember, where do I find grams? Grams comes from the periodic table, so I'm going to calculate that. So it's 12.01 plus 4.04, and you should get 16.05 for every 1 mole of CH4, okay? So grams cancels. Now I can move, now that I'm in moles, I can use my balanced chemical equation to move from 1 mole to the other, okay? So I'm going to set up another conversion. This time I need to cancel moles of CH4. So moles of CH4 will go on the bottom. I want moles of H2, so that goes in the top. And for every 1 mole of CH4, I will have 3 moles of H2. Moles of CH4 cancels. Do I have the unit that I want? The answer is yes. Now I can do this math. So I'm going to do 158 times 1, which is 158. So let me do this. So, I'm sorry, 158 times 1 is itself, divided by 16.05 times 3. And I get 29.5, and since I have 3 sig figs, I will have 29.5 moles of H2. And that's my final answer. Okay? All right. Now I'm going back to, in B, it says molecules of H2 gas from the 158 grams of methane. Okay, there's a couple of ways that you can approach this. You can go back to the 158 grams and do this again, or you can realize that you already have a mole for H2 and use that, and then use Avogadro's number to solve for molecules, okay? So B, we're saying, question mark, what am I looking for? The question mark that I'm looking for is molecules of H2. Now I've already solved for moles of H2, so I can say is equal to mole, I'm sorry, I need the number, I don't have the number, is equal to 29.5 moles of H2. Okay? So, and I'm going to set up a conversion. So this time I'm canceling moles of H2, so that's going to go on the bottom. And I want molecules. Do I have a direct relationship between mole and molecule? And the answer is yes. We have Avogadro's number. So molecules of H2, for every 1 mole, I will have 6.02 times 10 to the 23rd molecules of H2. So if I plug this into my calculator, just multiplying it by 6.02 times 10 to the 23rd. Oh no, I got a syntax error. So let's look at this. So I'm doing my 29.5 times 6.02 to the 23rd, and I should get, with sig figs, I need 3 of them, 1.78 times 10 to the 25th molecules, what should I have? Molecules of H2. Okay, I'm going to do one more, and then I want you to practice the last two by yourself. Okay, now what if I have grams of carbon monoxide? Okay, so now I'm not talking about H2 anymore. It wants me to calculate grams of carbon monoxide. So I'm actually going to go back to my 158. But you could technically use either one of these as your equals or your given, because if we remember, conversions just mean one. The only thing that we're doing or changing when we're moving and using a conversion is changing the unit. All of the numbers mean the same exact thing, okay? So let's look at C. It says, how many grams of carbon monoxide? So question mark, grams carbon monoxide. Equals, I'm going to go back up to my 158 grams of methane. So 158 grams of CH4, okay? So my first conversion, I need to cancel grams of methane, so it goes in the bottom, okay? I don't have a direct relationship between grams of methane and grams of carbon monoxide. The only direct relationship that particles have is mole to mole based off the balanced chemical equation. So I'm going to put mole of CH4 in the top. For every 1 mole of CH4, it will weigh 16.05. So grams cancels. Now I'm in moles. Now I can use the mole ratio from the balanced chemical equation to move from CH4 to CO. Okay? So I need to cancel mole of CH4, and I want mole of CO. So that will go on the top. Okay? Looking at my chemical equation, it is a 1-to-1 mole ratio. 1-to-1 mole ratio. So moles of CH4 cancels. Now I can move from moles of CO to grams of CO using another conversion. For every 1 mole of CO, it's going to be 12 plus 16 is 18.01. Or 18.01, sorry. 18.01 grams of CO. Okay? So moles cancels, I'm left with the mass. Now I can plug it into my calculator. So I'm going to go 158 divided by 16.05, sorry, you can't see what I'm doing, 16.05 times 1, which is itself, times 18.01, and you should get, with 3 sig figs, 177 grams of CO. Okay? Down here, you're going to be utilizing your 1 mole is equal to 22.4 liters. Okay? And then for E, it's going to be grams of H2O. So I want you to go ahead and try these 2 problems for practice, and then we'll do more practice in class. Thanks.